concept quiz will be Wednesday, and it'll be P1 and P2. And then we'll, so tomorrow, seniors in here, you'll come here, I'll take attendance, and then you're going down to the Hevalone for a meeting. For just like it's like make sure you have your credits. Here's what you have to do this year. So, tomorrow. Second or fourth hour on, no, this isn't fourth hour.
This is second.
Okay, so fourth hour, you'll do that. Tomorrow, you'll just come here and tell us
We're not
about
even
that.
here tomorrow.
Right. Then they'll give you the Cliff's Notes.
Waiting until like halfway through the third week of school to tell us
Hey, Allison, you want some gum?
Well, you still have time to pick it up now.
Amy, you want some
Huh?
gum?
It's fourth hour. Not. That's when you're going down for that meeting. I don't know what they're talking to you guys about.
You want some gum?
Yeah, will you throw it on there? Thanks. Because I still haven't gotten it. Okay, let's get going.
Hey, thanks.
Oh my gosh, I can't believe I thought this was fourth hour. And I thought it was Algebra 2 a second ago, so I'm all messed up. Okay, here we go. Let's talk about radicals. The square root of 25 is what?
5.
5. Technically plus or minus 5, but we're not getting technical today. Today we're just focusing on simplifying radicals. So this is what we call a perfect square, where you can take the square root of 25 and you just get 5. Okay? If I have the square root of 18, this is not a perfect square. So the only thing we can do for 18 is simplify the radical. The way we're going to simplify the radical is we're going to look for the perfect square that's in 18. So when I talk about perfect squares, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 25, 36, 49, and so on and so forth. You don't have to write that down. I'm just going to reference it. Okay. Okay. Okay, 18. If I want to break 18 down, I have a perfect square in 18. So I'm looking for two numbers that multiply to give me 18, where one of them is one of these numbers.
9.
So 9 times 2 is 18. So this is how I want you to do this. However you've been taught in the past, I want you to switch to this. I don't want to see factor trees all the way down. So we're looking for two numbers that multiply to give this, where one's a perfect square. The perfect child is 9. What's the square root of 9? 3. That gets to come out of the house. And I leave the square root of 2. So this is the simplified form of the square root of 18. Okay?
Why 9? Is this one of the numbers?
Because it's one of the perfect squares. You're looking for a perfect square. So let's do the square root of 72. What two numbers jump in your head for the square root of 72?
9 and 6.
Okay, so let's do 9 and 8, but that would be the one-stepper. This is how most of everybody would think, because this is even how I think. 9 and 8. Okay, which one's a perfect square? 9.
They both?
No.
8 is not a perfect square. Look at my list.
I can't see it.
Oh, you didn't write it down? Okay, well, you should know that. Okay, what's the square root of 9? 3. And I'm left with the square root of 8. Am I done with this problem? No. Because what does 8 have in it?
Comparatives.
Okay, well,
4.
4 and 2.
Yeah.
So I knew where you were going. 4 and 2. What's the square root of 4? 2. What are you going to do with that 2 and the 3? You don't add it.
Multiply that.
Multiply. So I have 6 times the square root of 2. So the point of doing this one is, even if you do one step and you get a perfect square out of there, you have to make sure what's left doesn't still have a perfect square in it. Okay? Now, Peyton said 36 and 2. And that is right, because if I would have broken this down to 36 times 2, what's the square root of 36?
6.
And you're left with the square root of 2. So that's right. That would have been what I would have called a one-stepper. But I wanted to show you just to make sure you...
Where is 6?
4 times, or 2 times 3. Square root of 4 is 2 times 3. 2 times 3 is 6. Okay. let's do one that involves a variable. Let's start mathing it up because this is the stuff I was hoping you would remember. Here I've got 45 x squared, the square root of 45 x squared. So first thing you want to always ask yourself is 45 a perfect square? No. So I can't take the square root of 45. So I'm going to look for something in 45. What does 45 break down to? I've used 9 a lot. 9 times 5. What's the square root of 9? 3. You're left with a 5 on the inside.
Can't pairs of 2 come out?
Well, what's the square root of x squared? X. And you're done. Easy enough so far?
Can you square just
Where are you getting a 3? Is it just 9?
Square root of 9 is 3. Okay, now I can move on to the examples they have. These were the ones I had for us to warm up to what they've got. So, you guys try this one. Are you banging?
Can you scroll back down?
Yeah. You can just ask. You don't have to.
Sorry.
Beat up the desk.
I've been like struggling. Okay.
Okay, so now we have the square root of 75. Actually, I'm going to change this one. I'm going to make it easier than the book has. Square root of 75 x squared. You guys do this one all on your own.
Sorry, we're talking about math.
I don't care.
I don't understand how you're just
Think of it like quarters.
Jesus, that's a really good idea.
All right.
Wait.
Junior's math testing.
So it's 9 and something?
No.
Is it 3 and, it's 25 and 3.
3 and 25. So which one's the perfect square here?
25.
25. What's the square root of 25?
5.
5. And then I have my 3 left in the house. And what's the square root of x squared?
X.
X. So I have 5x times the square root of 3.
Miss Hamilton, do I have to take the math test?
I'm gonna, yes. But I don't think so until, I'm gonna figure that out.
Do you know how board nesting is?
Okay.
Go with that house.
Oh no, we won't do that. Okay, let's talk about this one. Let's change that to an x cubed now. So it's going to change your variable a little bit. When you're dealing with variables, I want you to break the variable down to whatever root you have. So square root, what number is not written here, but we assume is there?
2.
A 2. So I'm going to break this x cubed down to x squared. So I'm going to have an x squared and an x. We all know how to do 75x squared. 75x squared worked out to be 5x, and you had a square root of 3. Because this x squared, you can do the square root of this x squared. It just becomes 1x. What do you suppose you have to do with this leftover x?
Leave it in the house.
Leave it in the house. So when we see variables, we're going to look at what the root is, break the variable down to whatever that root is, take out however many you have, that are that exponent, and then leave in the house anything left over.
Right.
Okay? So, with that, let's move on to cubed roots, shall we? We got to retrain our brain a little bit for cubed roots. Let's talk about perfect cubes. So I don't have to give you guys a squares and cubes test. 1 cubed is 1. What's 2 cubed?
4,
Cubed.
Nine. Or no.
Say 8. Thank you. Oh my goodness. Okay. I'm even scared to ask. 3 cubed.
27.
27. 4 cubed.
64.
5 cubed. 125. Okay. So these are my perfect cubes. This is what I was saying at the beginning. The cube roots are only difficult because our brain is trained for square roots. It's not trained for cube roots. So, Let's start with an easy one. Cubed root of 24. Okay, 24 is not on my list. So it's not, it is not a perfect cube. So I have to think of perfect cubes. Here's my list that we're going to break it down to. What times what is 24? 8 and 3. 6 and 4 are not on my list. Neither one are on my list. 4 is a perfect square, but it's not a perfect cube. So we've got 8 and 3. What's the cubed root of 8? 2. So that comes out of the house, and I'm left with the cubed root of 3.
Oh, this is, I'm gonna struggle with this one. I struggled with it last year.
I always struggle.
It's all right. Okay, now let's throw a variable in. I'll leave the number the same. Cubed root of 24, x to the 4th power. Cubed root of 24, x to the 4th power. So cubed root, we know, is 8 times 3. Cubed root of 8 is 2. So I have a 2 on the outside. I have a 3 left on the inside.
And you have x, or 3 x's on the outside and 1 x on the inside.
Okay, close.
Or 1 on x on the inside.
This becomes x cubed and x because I'm looking at the cubed roots. I want to break it up to cubes. So how many x cubes do I have? 1. So that comes out of the house. And then what do you do with this x right here? Leave it in the house. So let's do this next one. I'm going to change this up. I have the cubed root of, let's just say, x to the 5th. So we're going to break this down to x cubes because that is the exponent that we've got, or the root that we've got. So that is x cubed and what? X squared. What's the cubed root of x cubed? 1. So I have an x on the outside. And what am I left with on the inside?
X squared.
X squared on the inside. Okay? Whatever root you have, that's what you break it down to.
How many more examples do we have?
We're on the second one.
You
Like,
said-
yeah. We still have to add and subtract and rationalize denominators.
Oh, no.
I know. That's why I told you guys we had a lot to do today. Okay, can I leave simplifying? I am going to tell you this. Tomorrow in class, we're spending all day just simplifying radicals. You're going to have your homework today, which is just a handful of problems. And then tomorrow we're spending all day simplifying.
Is that a 5 outside of the box?
That was a 3.
Oh.
I just went to circle it.
So we have homework tomorrow then?
Yeah, I have a worksheet.
You
I've got it. Okay, let's move on to adding and subtracting, shall we? Okay, when you have radicals and you add and subtract, you can only add and subtract if the root is the same and the number underneath the radical is the same. So for example, if I wanted to add and subtract this, 5 times the square root of 2 plus 3 times the square root of 2, I can put this together. You just treat that square root of 2 like an x. So if I had 5x plus 3x, what would I have? 8x. Here you're going to have 8 times the square root of 2. And you can add those together because this number is the same and they're both the square roots, not the cubed root, not the 4th root. Okay, so let's look at this one. If I have 2 times the square root of 48 minus 3 times the square root of 27. They both have square roots, so that's good, but the number underneath the radical is different. So right now I can't do it. I don't have I need a recycling tub. I don't have one yet. Okay.
Okay, you know what, Naomi? Stop. You know what,
Okay.
So yes, so college.
So, what we're going to look at doing is we're going to look at simplifying these radicals before we put them together. So 48, I'm looking for two numbers that multiply to be 48, where one's a perfect square. And 27, I'm looking for two numbers that multiply to be 27. I would always start with the easier number, because that might give you a clue what's going on with the bigger number. So let's start with 27. What two numbers multiply to be 27?
9 and 3.
9 and 3. What's the square root of 9?
3.
So this we're going to multiply 3 times 3. So I have 9 times the square root of 3. So that means this 48 needs to end with the square root of 3. So 3 times what is 48?
12. Or no?
No.
3 times 16.
16. So is 16 a perfect square? Yes. What's the square root of 16? 4. So this becomes 8 times the square root of 3. And now we're able to subtract the two radicals. So this is 8 minus 9 is negative 1 times the square root of 3. So when you see add and subtract, the only thing you have to do is you have to make sure that they are the same number underneath. Okay? I got one for you guys to try on your own of these, and then we will rationalize the denominator, which is easy. So you guys try this. 32, or 3 times the square root of 32x squared plus 4 times the square root of 8x squared. Okay, I'm going to start my work up here. If you're stuck, you can watch mine. Otherwise, we'll go over it when you're done. Okay, because I started with my smaller number, I knew what I needed this square root to end in. I needed the square root to end in 2. So here, if I was just looking at 32, I probably would have gone 8 and 4, which is fine, but then that's a two-stepper because 8 still has an extra 4 in it. But because I knew I needed to end as the square root of 2, I thought, okay, 32 divided by 2 is 16. So I started with 16. 16 is 4 times 3 is 12. And then square root of x squared is x. Here, square root of 4 is 2 times 2 is 8. X times the square root of 2. So if I added this together, I get 20x times the square root of 2.
Could you add something if like one of them was like 8x squared and the other one was just 32, or would it have to be?
No, that's a good question. You couldn't because
Add 'em.
you'd need the x. Yeah, they need to follow that rule too. Okay, last thing I'm going to show you because I'm going to let you guys work just to practice. Last thing I'm going to show you is in math land, it's bad to have a radical on the bottom. And you guys have all seen this because we did this for a little bit in Algebra 2 and for sure if you were higher than Algebra 2. But we're going to do what we call rationalizing the denominator, and that's multiplying the top and the bottom by whatever that radical part is in the denominator. So I'm going to multiply the top and the bottom by the square root of 3. When you have the square root of 3 times the square root of 3, you get the square root of what? 9. You just multiply the numbers underneath the radical. What's the square root of 9? Everybody in this room knows that answer. 3. It's always going to work out to be whatever that number is. So if I had the square root of 5 times the square root of 5, it ends up being 5 because it's the square root of 25, which is 5. And then on the top, you can't put those together, so you just leave it like this. And that's your answer. You guys kind of remember that? Okay. What time are we done? 52. This is perfect. I just have a handful of problems. I want you guys to try. And then if we go, we might be able to go over it in class today. Because there's not very many problems. 79 to 82. 89 to 90. And then 101 to 103A only.
Do you know how much a handful is?
That is a handful.
Handful is like 5.
Okay, well, so it's a little more than a handful,
few
but
handfuls.
no, it's not a few handfuls. 79, 80, 81, 82, there's 4, 6, 101, 102, 103. It's not even 2 handfuls. It's not even